All right, how's it going, everybody? We're going to get started with the second half of the course. You guys quiet down a bit. Cool. So the first half of the morning, it was a lot of overview of the render tree and kind of the nitty-gritty of what modifiers are, what surfaces are, views, context, that whole thing. So the other part between knowing, go for it. Besides just knowing like the fundamentals of how the render tree is constructed, is actually knowing what higher level functionality we have, what components we have built that you actually don't have to go build yourself. So we're going to spend the next 15-20 minutes kind of going over some of our layout widgets, what they do for you, how you can use them, what the different APIs are for those, so that instead of you going to build your own grid, you can see what our own grid does for you. So today I'm going to talk about primarily 5 different layout components. 3 of them are very similar together, and 2 of them are also very similar together. So grid layout, flexible layout, and header footer layout are all really interesting components because they all take into account what your parent sizing is. So what they do is if I'm talking about the entire window, it'll fill my entire window for me and create a grid based on the amount of usable space I have. If instead I didn't attach my grid to my main context, which is the whole window, and instead attach it to a modifier with a particular size, it'll actually divvy that size up for me instead of the entire window. So if we look at the code for the grid here, we can see this. So if instead of just adding it to the main context, I add a modifier, required famous core/modifier, and let's say we have var mod is equal to a new modifier, and it has a size of 300. If instead of adding it here, and we do this, so the text is off because of the styling, but you can see that now instead of taking up the whole window, it only takes up a certain amount of space. And this is really great because you can think about using a grid as part of a different view. So if I have a view in such as the Polar tutorial where instead of having that card come down, I had a certain size and I wanted to have a grid in there. So say I wanted a calendar widget or something, I could have a layout that's completely flexible based on the size. So if I take this out, every frame, the grid is deciding how to lay itself out and all of its components. So if I resize this window, you'll see that based on this, I end up having a really responsive, design. So there's a few things with grid layout that I'd like to go over. One thing is the dimensions. It pretty much, as you would expect, it defines how you have the different layout of what you have. There's also a gutter property. So instead of having to manually code your views to have different padding on everything, you can actually specify to your grid however much guttering you want. So let's say I wanted horizontal guttering of 10 and I wanted vertical guttering of 20. You can get that for free, and it pretty much will lay everything out. Again, very responsive. Take a look at so a lot of what I'm doing right now is covered in some of the university content also. I'll go through some of these lessons. But for instance, if you take a look at, let's say I have more collections or more surfaces in my grid than I do spaces allowed. So right now my grid is sequencing over an array of surfaces. So that is an array of renderables that it's trying to lay out. So right now we have 50 renderables that grid layout's responsible for laying out. But because my dimensions were set to 4 by 2, I'm only going to be laying out the first 8. So grid layout, if you have too many things, it'll only lay out the first 8. Likewise, if you have too few, you're going to end up with a bunch of blank space here. But it still coordinates or sections off its context based on the dimensions you specified. So in the prior cases, all of the surfaces had size undefined, undefined. And what that means is they end up filling their amount of usable space that they have allotted to them. instead of having a size undefined, undefined, if you have something that has a particular size associated with it, let's say these things here, we see that they're positioned inside of their little area, but they don't fill the entire thing because they're actually going to use their own size and not defer to whatever their parent sizing is. So I covered this already, but another thing that grids have is they have a transition option. So if on click I want to transition from 4 to 2 to 2 to 4, we can see when I click in here, you get the ability to reflow your logic as you want. So what you could do is something like, I listen to a window resize event, and based on my window width or window height, I can resize my grid as I want and get a really cool like reflow effect with curving and even physics if you want. So I'm going to go now to the next element, and I'm going to talk about header-footer layout. So header-footer layout is very similar to grid layout, as it, again, uses its parent sizing. So what grid layout does is it has three...
Questions or saying?
Yeah, take questions whenever.
So I want to hear just English spanning cells or something like that.
So, sorry, what was it? Can you do spanning cells? Such as?
I want to have some content go over 2 columns.
No, that's not supported right now. But you could combine that with other components to get what you want. You could have a grid. Right now, you couldn't I couldn't say this thing is actually too wide and then this is. But you could actually use some of the other layout components to make that yourself. So header-footer layout. So header-footer layout is very useful for what you would see in like your stereotypical iOS app. You're given space at the top, you're giving space at the bottom, and then whatever's left in the middle is what you fill with your content. So if we look at the API for this, what ends up happening is we can see that I have a specific header size defined, a specific footer size defined, and then I add to all three of my things, my header, my content, and my footer, my different surfaces. So one thing that's really useful for this is if I don't want to specify a header size, for instance, what ends up happening is because there's no header size defined and my header is undefined, my header will not be laid out properly. So if instead of defining the size on the layout itself, let's say I decided I wanted my header to be 100 pixels itself, if you don't specify a size on the header or on the footer, it'll defer to the size of whatever you added to it. So this allows you to, if you don't want to control the size of your header and your footer in your layout, you can actually control it by the specific component itself. Similar to how grid layout was, I'll just, again, if you add a new modifier, you can see that the grid is, or the header footer layout is confined to a certain area.
So can you embed a layout in another layout?
Yep, you can do it as many times as you want. So you can make some really cool things by including, I could do a header footer layout with my content being a grid, or a lot of times you'll see, actually, if you look at the, I think it's called tab bar in the widgets library, it's essentially a grid layout that is often used in the header, in the footer. So the next one I'm going to talk about is flexible layout. So flexible layout is really similar to HTML5 Flexbox. Interesting. Cool. So as in HTML5 Flexbox, everything in flexible layout is defined by a ratio based off of the whole. So flexible layout can either be laid out horizontally or vertically. So for this thing here, we have 4 renderables inside of our flexible layout. So if we look at this, we can see that I create my 4 surfaces, and I create my flexible layout with these particular ratios, 1, 2, 3, and 4. So as you can see, of my total space, this is taking up, what is it, 1/10, this is 2/10, 3/10, 4/10 of the entire usable space. So you can change these. So if I do flex.set ratios, instead of 1, 2, 3, 4. I want 3, 2, 1, 9, or 8. Okay. Let me change it here instead. 3, 2, 1, 8. You get a different result. Something that's really useful about flexible layout too is instead of specifying just a ratio-based amount to have it calculated for you, you can set a value of the ratio to be true. And what that means is it'll end up using the defined size of whatever that renderable is, and then using the remaining amount of space to do the percentage-based calculations. So we can see what this looks like. So let's say I wanted this blue surface to always be 10 pixels. So blue was the third one, so let's say I want this as 1, 2, true, and 1. So when I iterate through, I can say var size is equal to I is equal to 2. If it is, the size will be 10 pixels, undefined height, or it'll be undefined, undefined. What? Oh, good call. So we can see now that no matter what this size is, this blue bar is going to be 10 pixels tall. So it's really nice for making some complicated layouts because I get the ability to both have parts of my layout that are statically sized and have parts of my layout that are going to be sized on resize or on when anytime my parent context changes. Similarly, I won't go into, you'll see it if you go through the university course, but flexible layout also takes a transition property similar to how grid layout does. So if I wanted to set my ratios from 1, 1, 1, 1, 1 to 1, 2, 3, 4, 5, and I set it to click, you'll see that the ratios actually expand and contract. I can go through that now, actually.
I have a question.
Yeah, what's going on?
So surfaces I know aren't responsive, but the layouts are. How are they responsive? Is it an event that's emitted? Because the surface, if I recall, I was working with them and it wasn't adjusting itself. So
surfaces have they have a sizing property attached to them. So if you define a surface that's size 100 pixels by 100 pixels, it's going to be 100 pixels by 100 pixels. But if you set a size on these surfaces, you can see that, see here all these surfaces are sized undefined, undefined. They actually fill the amount of usable space that they have at their disposal. So what these layout widgets do, or these layout components, what they do is they end up divvying up the amount of space and passing that to the surfaces so that the surfaces pretty much can understand how large they need to be. So this is what I was talking about with the transition option. You can see that I have this transition that I ease in, ease out over 2 seconds, and I transition my ratios from 135 to 531. Okay, so those are the components that use. So those are the components that use parent sizing. Yeah, question?
Can you combine the layouts?
Yeah, definitely. So I could have. I guess we can do that right now. So if I have let's say I have a grid layout here. Let's say I have this header, or let's say I have this flexible layout, header footer layout. There is? Oh, perfect. This one here. Thank you, Shu. Okay, yeah, perfect. So you can see here that this one here, there's a header, a footer, and a content. And this inside part is actually a grid layout where these things are sized. It's a 2 by 1. So it's split down the middle, and then each of those things, this content is actually a grid layout. Yeah. Similarly here, you see a header and a footer, and these are actually grid layouts that have them attached. So the thing that was really great about these is that they use parent sizing to divvy up a hole for their children. The other thing that sometimes you might want to have when you just want a list of things is to not divvy up a parent size, but to just lay my things out sequentially. I want to lay this one out, and then because this one's 200 pixels tall, I want to lay this one out translated down, and then this one translated down and down and down. So what ends up happening is you get what we call sequential layout. So what sequential layout does, as I said, it just goes through and based on the size, every frame it iterates through and it translates in a specific direction based on the size of everything before it. So you can see that because these are all sized, we get a list. If these so the reason they're filling up the whole window is because we're doing some magic with window.innerWidth. If instead of that they were all 300 tall, you'd only see some of them, and they'd fall off the bottom of the screen because they weren't there, because there's no scrolling attached to it. Likewise, this also has the ability to be laid out in other directions. I kind of glossed over, I didn't really talk about this in any of the other ones, but flexible layout, header footer layout, and sequential layout all have the ability to do horizontal and vertical layout. So as you can see here, all of them are laid out horizontally instead of vertically. This is also the case for scroll view. It's actually kind of more of what we have as scroller that does the layout, but when you end up using the scroll view, it has an implementation of scroller. So like sequential layout, it's going to defer to the defined size of all of these things so that they're laid out properly. And when you go through, you see there's no overlaps because all the sizes have been defined properly on these. So the last part sorry, what's?
The Scroll View tutorial is not yet in the university.
Yes.
When do you expect it to happen?
Not totally sure. Probably not in too far off in the future. We're actually coming out with kind of a nicer implementation of scroll view that does some of the nice to haves for you, such as getting the absolute position. Like how far through this thing have I actually scrolled? That's one thing that we don't have in our initial implementation because our scroll view is kind of more designed for the endless amounts of information case, like the Facebook newsfeed where there is no such thing as like, where am I? So once we get that out, I think is when we're going to start having the full scroll view lesson.
If you want to see the example of scroll view, if you go to our docs section, we actually just added the live, like where you can see the code and see the demo build live. We've added a lot of examples. Mike has done a lot of that work of scroll view. So you can get an example from the ref docs there. But a scroll view is one of these widgets that has a lot of details in terms of its implementation. There are a lot of ways to modify its use to do a lot of really cool things. So we know that that lesson is very valuable. So that's definitely on our priority list.
Cool. So the last thing I'm going to leave you with, we'll probably get into this later today and into how to extend this ourselves, but we just came out with this thing that is called contextual view. So what contextual view does is it pretty much gives you the same API that Vue does, but it's parent-sized aware. So similar to how if you wanted to make your own grid layout or make your own flexible layout or header footer, something that's going to expand and needs to understand like how big is the thing I'm actually inside of, you can extend this contextual view and it's the same API as, it gives you the same things as Vue does given you're given an options manager and event handlers, but it also has a commit function that will allow you to do specific logic at like every frame based on your parent sizing. So hopefully we'll get into that a little bit later today, and I can walk you through an example where we can make a view that's parent sized. So we're going to go and hit up Waldman for the inputs lesson. So he'll teach you all about how to use our different syncs, the touch, the scroll, the mouse sync, so that you can build like really complex animation based on user interactions.
Most of what I'm going to be talking about is going to be inside of Famous University, but you're going to have my voice to guide you through it. And I'm going to mention some things that we can't do on Famous University because it's a little bit more multi-touchy, and Famous University is kind of a desktop experience right now. But I'm going to be talking high level just about inputs, which is the internal word that we use at Famous to discuss, okay, I'm touching the screen, I'm dragging along the screen, I want something to move. And how do I make something move based on any kind of user input? So whether it's they're using a mouse, whether they're using their finger, whether they're using both, scrolling, then we have all this kind of gesture recognition for multi-touch, which is about pinching, scaling, rotating, and there's going to be a lot more coming in the future, like swipe right, swipe left, all sorts of other interesting stuff. Shaking would be an accelerometer thing. I guess that would fall under the purview of inputs. We don't have that yet. You'd have to use the native Windows stuff. But that should definitely be in there. And since I'm the physics guy, I love the idea of like making a little labyrinthy maze that you can walk around based on the accelerometer. That'll be coming too.
Did you just promise that?
Yeah, you heard it here first. Enhance. All right, sweet. So you guys all have this. Let's go over to inputs. Okay. Okay, so once again, high level, you want to touch the screen and you want something to happen. So this is going to be, you may have seen this example already, where we're going to be just dragging this square around. The interesting thing here, though, is that this square is just a surface. Okay, there's barely any lines of code here. Let's refresh again. There we go. So there's not very many lines of code here. It's just about creating a surface. But then the tricky thing that you guys haven't been introduced to yet is, okay, my finger's on there. Now how do I make the surface move? So a surface has zero idea of where it is in space. All it knows is like of its own, like I'm a div. So this might be a little different from the jQuery way or other kind of libraries where you query for the actual DOM node, and then you say like .draggable, and then you can start dragging it. That would kind of imply that surfaces have like an isDraggable method, or is scalable, or is this. But in Famous, surfaces are extremely dumb objects, and any kind of logic about moving them, scaling them, changing them, that's all done in the render tree, which is where we started with. So there's going to be a modifier that actually does the translation. Okay, and the surface doesn't know about dragging or anything itself. The modifier tells it where to go. That's the big picture. So there's going to be a few pieces here. One is a sync, which is actually going to capture, well, sorry, let me back up for a second. So when you touch the screen, there's only a few things that can actually hear that. We call that an event source. So the body.addEventListener in the native world, you can listen on mouse move or something like that. So what controls the body's movement is kind of the engine. You can listen on the engine. But you can also listen on any kind of div element too. So in this case, it's the surface that's going to be the event source. So when I touch the surface, it's going to be the first thing that hears it. But now that surface has to tell not itself, but the modifier above it. Did I just go out a little bit? The modifier above it, what its position is. So that's kind of the weirdness of Famous, is that surfaces don't know anything, only the modifiers do. So at some point, the surface has to tell the modifier where to go. And then the modifier tells the surface where to go. So it's this back and forth. The event comes from the surface, and then the modifier changes the modifier, and the modifier updates the surface's position. So let's see how that works in the code. I like starting at the end and then going backwards a little bit. So what I just said, highlighting doesn't really work very well, but lines 42 to 45 give you the idea that we have the surface at the end of the render tree, and then there's a position modifier that's actually going to always know what the current translate is. And then we have a way of just centering it, but that's not important for this demo. It just puts the square in the center. So this position modifier, let's just literally go from bottom up. This is great. That position modifier is, this is what's kind of hidden inside of Famous, is that like, when are things updating? This guy has this transform property that's a function. That function is going to get called on every single tick of the engine, behind the scenes, essentially. And it's going to return a transform that has a translate property. And that translate, every time it's called, position 0 and position 1, the x and y, are going to be slightly different values that relate to the current position of the scroll view. So does that make sense, at least, that all we know right now is there's a surface, and there's a modifier above it that has something to do with positioning. And if I change these position variables anywhere in my code, oh, God, oh no, I press back. Does I multi-touch on the browser, however, it's kind of down, down, right there. Cool, great. So okay, let's do some live coding. I'm gonna change that 10 to an 100. Oh, look at that! Like it turned out that because of where I changed it on the very top, when it came down to line 33, that translate is now a 100, 0 for the x and its y. Okay. Now those values are just going to live update as I'm touching the surface. So let's bring it back to 0, 0. Okay. Now let's get to the juicy part, which is actually how does how does the sync work? Okay. So that's kind of why I started talking. So here I'm gonna create this mouse sync. So I'm only going to be listening on mouse. We have a touch sync. We have all sorts of syncs. We have one sync to rule them all, called the generic sync. We'll get to that later.
Should have called it the kitchen sink.
Duly noted. Okay, so so all the juice happens right here. So I told you that the surface is the originator of the event, okay, and it's going to then pipe to the sync. So what that means is that now the sync is actually listening to all the surface's events. So mouse move, mouse down, mouse up. Mouse leave, mouse, all those things. What you do with them is going to be discussed in a second. So if we had a touch sync, that would be listening on touch start, touch move, touch end. Mouse sync only listens to the mousy events. And then it's in the logic of sync itself, all of our syncs have a start, update, and end. So if you use a mouse sync, mouse down translates to the start event. Mouse move translates to the update event, and mouse, where am I? Down, up translates to the end event. And then mouse leave also translates to the end event. So like, there's a lot of like details with all the mouse stuff, but that's the big picture, is that there's a start, update, and an end. And instead of listening to things like client X, client Y, page X, page Y, offset X, offset Y, if you like console logged all the things that a mouse event gives you, you'd have this giant list of stuff, to put it nicely. So we kind of minimize all of that information and give you maybe what's a little bit better for your exact purpose. So we give you a position, we give you a velocity, something that native doesn't give you but is really important for us. We give you a delta, which is what we're going to use here. We also do give you offset X, offset Y, client X, client Y, but if you're looking for dot target, that won't be there. There are a few things that we don't give you because the ultimate end idea is to translate this over the wire, and things have to be JSONable, detail, whatever. So what's important here is that as I touch, position is 0, 0, I have this update event that the sync gives me. The first argument into that is going to be this JSON object that has position, velocity, delta, blah, 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 a lot of stuff. And now I'm just going to update the position based on the delta. So I'm going to just increment the position variable based on the delta. That's it. That's how it works. And that's how you get something that can be dragged. So the surface is dumb. The surface has no idea what's going on. But that position variable is being changed. And then it's being always called inside of that modifier, which returns the current transform every single tick. I spent a lot of time just talking about lesson 1, but like everything else is going to be simple once you get once this is simple. So any questions at all? Confused? Yeah.
Could you explain how delta, like you're getting delta 0 there, delta 1?
So I wish I could like console log this, I guess, and you could see it. Would that work?
You could set content of the surface.
Sure. Check this out. Advanced move. And then, so would that work? Oh yeah. Oh, look at that. So it's an array. Delta just gives you the diff. Oh, enhance.
Make the font size
Now it gets all surface. Okay, check this out. This is what we call in our company enhancing. Whenever we want something to be bigger. Whoa! So I'm a platform engineer, not a designer, but this is perfect for me. I don't know if it's perfect for you. Okay, so but let's now that we've made this hack, let's see what else we can do. Data.position. Okay. Well, that should be fine. This is what happens when you. Okay, weird. Here's the velocity of my drag, which is going to be important a little bit later. So there's all sorts of attributes that you can get out of this. I think I also have offset x. Okay. So a lot of DOM-y stuff and a lot of particular famous-y stuff.
Question.
Yeah.
Maybe this is just semantic and we can go over it, but if the frame doesn't know where it is in space, how does it record the delta positions and how does it know its velocity? It doesn't know how fast it got from one place to the next.
Yeah, that's a great question. So I imagine that when I touch, I start at 0, and I'm logging. I'm actually keeping a history of all the touches internally over time, and I'm just comparing the new touch versus the previous. So what's happening internally are these deltas are just being accumulated internally to give you the final position. And so on the inside, the sync is actually just keeping track of all the events and accumulating them together. So it starts at 0, and you always get the diff. You can always hear what is my current, internally it says what is my current client X, and then what is my new client X? What's the diff of that? Let me add that to 0, and then accumulate over time.
Starting point, not just the previous point?
Well, what it gives you is always the start, and you can query for client X, and that'll tell you where you are on the page. And sync.onStart will give you where you started from, if you want that. So I think we'll use the other events a bit.
I'm trying to find what visual parameters you have for data. Where would I look at what data I can pass?
Right. So the question is, what are the other properties inside this JavaScript object? That should be in our documentation. If it's not, we can definitely add that. And then always, though I hate having this as the answer, but you can just look in the code. I mean, that's the answer all the time. But yeah, that should be in our documentation if it's not already. Should add that. Yeah.
Does piping two objects or two surfaces or a sink and a surface, does that add a lot of overhead?
No. Well, I mean, it's the minimal amount of overhead, essentially. I mean, you still have to do the eventing, which is always overhead, and there's some extra function calls. But we try to be as performant as possible. And what's important inside of Famous is that all the piping that we do is done manually, so we don't use DOM's native piping. We create our own eventing library. So our .pipe is a Famous thing. And so it doesn't bubble, which is the main performance benefit. So in DOM, there's all this bubbling that you have to deal with, and if you don't want it to bubble, you have to manually stop it from bubbling and all that. So here, everything is kind of a manual process. So this shouldn't pose any performance problems.
data offset x?
That if you,
To when you start or something? Because
That-
I just tried it here and it just seems like I get numbers going from like 3940, 3940.
yeah, so actually, so the offset x is a DOM property, and that tells you where relative to the top left of the actual div you've pressed the button. So as you scroll, if it follows your mouse, those actually should be pretty much in sync with each other, except that you move your mouse faster than the events can fire. So sorry, offset x was a bad example, but page x would be a good example. I'm not sure if we omit that one. Anyway, all right, let's move along to something a little bit more interesting. So in this case, now we drag, except we're going to combine some other famous componentry where we want it to return to its home position when it's done. So that's the only thing that's happening here. So the only difference is that when I let go, I want it to keep moving. And you might think that that's a small tweak, but that's actually a new component inside of Famous called a transitionable. I think did you? Okay. Earlier on in university, you've been introduced to transitionables though. And the idea there is that a transitionable is just a way of going from one number A to one number B with a curve, like a easing curve, or just linear over a duration of time. The reason why we need to introduce this concept now is because when I let go, I don't have any more user input, yet I still need to do something over a period of time. So if you can imagine that the position state is now inside of this thing called the transitionable. Transitionables API is really simple. It's just really a setter and a getter, except unlike maybe the backboney set get paradigm, you can set with an easing curve. So you can say go to 100, but do it with an ease in transition over a period of 1,000 milliseconds. Okay, so it's just set and get is all that's going on. When I let go, I'm just going to set position back to 0, 0. Make sense? But now I can't refer to those position properties by their like position entry 0, position entry 1, because position is this thing called the transitionable. I have to call position.get, and that will give me the array that has a 0 and a 1 entry. So
what's the difference between a modifier and a state modifier, and when do you use the two?
Yeah, that's something I should address. Great question, Shu, Dean. Okay, so maybe with that question, let's go to the example that we're all with dear to our hearts, the very first one. Maybe you haven't seen this line 35 through 39 API yet. Maybe you're more used to saying position modifier.set transform, position modifier.set opacity, and not like explicitly calling sets on the modifier instead of having the modifier read from something. So this is actually required in you'll notice it's not state modifier, it's core modifier, line 4. And they're extremely similar in what their purpose is, but different in their implementation. So to Shu's question, in state modifier, it consumes its state. It knows what its position is, what its transform, opacity, origin, alignment are. It knows all those things. It doesn't query for them just in time. This modifier, however, is a query for just in time kind of thing, where it actually doesn't know what its transform, opacity, origin, and alignment are, but it has a function which tells it what it is on every single tick. Okay, so you wouldn't say position modifier.set transform here. You'd say position modifier.transform from, give it this transform object, and it's going to keep querying it all the time. It's going to be like, what's my current transform? What's my current transform? Behind the scenes. So that's a little bit of the philosophy of it. So hopefully these lines of code aren't scary. The only thing that you have to know is that this transform is being queried. That function is being executed on every single tick. And it's not being set externally inside of your main.js or whatever we call this. You could equivalently say position modifier.set transform and give it the transform every single time. But then that like this piping is done once, and you never have to worry about it. The only thing you're changing is now position, instead of always changing the modifier. So, okay, cool. So sorry if I skipped ahead and introduced the concept that we weren't all on the same page on. Okay, so sorry. So now to go back to the example where you're dragging and goes back home, still the same modifier is being used, the one in core. And now the difference is that in line 10, position is not just the array 0, 0, it's a transitionable. Okay, now transitionable has set and get. On update, instead of just actually changing the 0 and 1th entry, we're setting them a la Backbone. And when get is really called, gets called when the transform function is being called in position modifier. Instead of just returning the 0 and 1 entry, we're first calling get on it, and that returns the array. So you don't get the actual array, the meat, until you call get. But get is always the correct value just in time. The reason for this complexity is now on end, I can just set it to 0, 0 with a transition. That's lines 28 through 31. So end is called right now, and then it goes back home. Let's make it go back somewhere else. Live coding. There we go, 100 down or something. So now, but like everything else works, it'll now go there. Thank God. Okay. And you can change the transition, the duration, and what we're going to do in the very next step is going to make it physicsy. So it's actually going to use the velocity information that you get from the drag. Any questions of like kind of how you use transitionable in this context?
So, I'm sorry, just to recap, state modifier knows its position, it's always set, whereas a modifier, it does it on every ticket.
Yeah, that's right, right. So if you want, like right now, if you, in our old Hello World with the spinning logo that you've seen, that used the state modifier where it's just a logo spinning around, and you're like, how is it, what's happening? How's it doing that? And it's just like, all you are is you're changing a single number, the rotation value, instead of calling set modifier dot transform dot rotate ze or y with a number. All you're doing is changing the number, so you don't have to go through the heaviness of modifier is a pretty heavy object, but you can think that its position and its scale and whatever it could be defined outside as very small objects.
Have that in their starter kits.
Great, yeah. Yeah, so in boilerplate in your starter kit, you'll see a really simple example of that spinning logo example.
So the state modifier, the modifier refactor is done in the capstone project for right after Baldi's lesson. It's called Timber. So in that lesson, you actually start using a state modifier, and then you get to a point where you actually need the refactor to a modifier. So that one, you actually go through, you actually understand, oh, this is where I need to switch over.
Yeah, we find that state modifier is simpler for people to understand, but sometimes it's limiting in its applicability, and we created this other modifier, but right now we're keeping both. Okay, so before I get to the physics, let me actually show you that every one of these has like a capstone, an end. So let me show you the capstone, and then we can see why the physics is actually important. So this is the final project here. And it's this arrow guy that just rotates. Oh yeah, let's make this bigger. Sweet. So this is really in Timber or in any kind of hamburger menu that you might have seen in UI. There's like a button you press, and then the thing moves over, and then you have the drawer panel that's there, and then you can slide it back and forth. And sometimes it's just a button that you click, and it opens and closes. What's really cool is when you can kind of drag the panel left and right and fling it if you wanted to and fling it back. So the fling is why you need physics, because if you just used an easing curve, no matter how you moved it, the fling would be the same, you know, so it wouldn't, like, if you threw it, it would still like to the side. So like the second you let go. So you want to use the velocity information that you have. So here, it's kind of hard with a mouse. Like if you had this on a touch, it would feel better. but this is the idea. So, and if I don't throw it hard enough or whatever, it won't move. But if I throw it too hard, it'll move. Okay, we'll get there. Text. Let's go back to where we were. Oh. Okay, I think this is where I was. Yeah. Okay, so here you'll see. So this is a different kind of transition, but like check this out. I'm going to throw it up, and this is a tight spring here. Let's make it less tight. Wow. Okay, so now when I throw it up, it still goes up and like to the left. You know, if I were to go back to the previous example and try to do that, this is now with an easing curve. It won't go up. It'll just like move. I am a robot. I go home, like that, right? But like sometimes you want a little bit more like fluid, like I want to accept user input and then go home. That's where physics comes in. So you briefly also before we introduced some springy kind of transitions that came from physics. Here we're going to do the exact same thing. The only difference between these two codes is if I go back for a second. Here I set the position with an ease out bounce, and in the other one I'm going to set the position with something that we call a physics transition. So it's a little bit more nerdy, but you define this spring, which we're going to do up top. There are some physicsy parameters of a spring, like its period, how bouncy it is. Also its damping ratio, which is how damped it is, how quickly it slows down. But the key thing here is the velocity. So we're gonna get the velocity information from the sink, and then use that just by instead of transitioning with a curve, like it's just another parameter into that transition. And the only boilerplate that we need to do up top is line 7 through 9. So the only diff between this and the previous lesson is line 7 through 9 and that different JavaScript object we passed in as on the end event. Or really lines 8 through 9. So this snap transition is a physics transition. It's like a really sharp spring. And so all you do is you require that in, and transitionable. Okay, this is a little bit of weirdness, or a little bit of different. Is once you do this register method trick inside of your app, anywhere inside of your app, hopefully main.js or like app.js or something like that in the beginning, you can now use a spring transition anywhere you want in your app, the same way you'd use an easing curve. Like Famous, by default, starts with just like really simple easing curves, linear, ease in, ease out, bounce, one or two others. But any other easing curve can be like added in as an afterthought with just a couple lines of boilerplate. So you just require in the transition that you want inside of our transitions library, and then you give it a name. Here we call it spring, but I can call it, I can spell it wrong if I wanted to, sprung, as long as I'm consistent when I call it with the method name, and it'll still be fine. So you just give it whatever name you want, and you assign it, and you reference the actual object that you want it to queue. And actually, this is all magic that's done behind the scenes for you, is just when you give it that definition and that method has the right word, sprung, it'll call this transition, this physics transition, to go from A to B. And now here we use the velocity information. So that's the diff. How are we with that idea? The big thing to get is that like you do that in your main.js, you register a spring transition, you use it anywhere in your app. So whether it's like 4 files down in this nested hierarchy of stuff, you just have a method sprung and whatever, and it'll work out. So it's super easy to make any of your easing curves into physics transitions just by giving it a different little object. Yeah?
So does generics no longer default register classes? Do you have to manually register them?
Yeah, so this is different in 0.2. It's slightly backwards incompatible. So now you, just like I was talking about with transitionables, a register method API, generic sync has a register now, where in your main.js or app.js, you register all the syncs you want. We're going to get to this in a second. So whether if your app listens to mouse, touch, in the future, you have to imagine that we're going to have leap motion sync. We're going to have Milo sync. Like for every single device we're going to have remote control sync. So like for every single device that you think, right now the world is a very mouse and touch world, but in the future the world is going to be, inputs are going to be pretty generalizable. So our generic sync is just like, what are the things that your app listens to, and we're going to make sure they have start, update, end. And then once they have start, update, end, everything else in your app will use that logic instead.
Can you stop the motion in the middle? I mean, if I started and then I want to...
If you're fast enough. So
how do you stop the transitionable in the middle?
So transitionable in general has a halt method on it, which will just stop it in place. But if your concern is what happens if I touch it many times or something like that, that's built in. So if you're fast enough, or we can just set the period like to something crazy. Oh God. Oh no. It's gone. It's so gone. Refresh. Wait, what if I, oh yeah. Okay. Okay, so 3 seconds is a little bit more reasonable. So like I can, when I touch it again, oh, so I don't have a start update. I'm not listening on start right now, so if I was listening on start, I could just set its position to whatever. Right now it's on move that I keep. Sorry? Yeah. So anyway, I can interrupt the transitionable can always be interrupted at any time and set its new value at. You can actually define whether it's kind of a sequential thing or a override thing. Okay, generic sync. Dun dun dun. So the only difference here is now this thing can also be scrolled. So it's hard for you to see what my hands are doing, but I'm scrolling, just so you know. Before, nothing was listening on scroll. This is just a kind of an abstract. Typically, the use case is to listen to both mouse and touch, but since this is a desktop-only experience, I'm listening on mouse, touch, and scroll. I could probably put this in emulate mode, and it'll also respond to touch events. But the idea here is that both mouse and scroll can be listening here. So there's a common problem on the internet, maybe you've heard of it, is that I want to make a mobile app, but I need it to work on desktop. So how do I listen to both mouse and touch, right? So this is then you get into all these philosophical debates about the new Chrome Pixel book, has both mouse input and touch input. This guy over here had a tablet with a mouse, or a thing that you could touch somewhere over here, had both like touch support and mouse support. So there's a lot of weirdness when it comes to just moving mouse into touch or just moving touch into mouse and that's it. And plus they're slightly different in their implementation. So if you want to just listen to both and one will be ignored, that's our current philosophy. Okay, detail. So that's the only difference here though. Oh, and generic sync. So okay, so just like transitionable had this register, and it's kind of like this global thing. You do it in app or main.js and it's app wide, or you can do it anywhere and it's app wide. You kind of describe all the things that you want to receive as user input. So mouse, touch, and scroll, and you give them keys. And then later you create your own sync that listens to a subset of those keys. So here, I first register this, think of this as like being app-wide globally in your app, and now I create an instance of it, and I can take mouse, touch, or scroll, and with any kind of optional arguments that I want, like scale. Yeah?
So can you scope this into particular contexts as well?
Can you, right now this is app-wide, so not even context-specific, but like all your contexts belong to generic sync. Yeah.
Is it going to be that way? Or?
So why would you want to be context specific about it?
Yeah, that's what I was asking.
So when you register, you kind of register all the things that you are listening to. The things that you're actually using are specific to where you instantiate the generic sync. So think of this as like, this is the garage sale. My entire app listens to mouse touch. Sorry, not that one. This is the garage sale, lines 12 through 16. There's like everything that I could be listening to in theory. And then lines 27 through 31 are like, oh, well, let me create a single sync now. And which of those am I in particular listening to in this widget? So if one of your widgets doesn't listen to scroll, then you just don't, you create a sync, but you don't give it the scroll key. So here, let's do it. So now this thing doesn't listen to scroll. I can't prove it to you. There you go. Not scrolling.
So basically, each context will have its own sync.
Each widget. Each everything, yeah. So you on some main level you have like, what does my entire application do? And then on each individual level you have like, what does this specific one do? So you have the granularity there. Okay, and I think all the other boilerplate is exactly the same. So the real kicker is that here we've always had this line 39 surface.pipe sync, except before Surface was only emitting a mouse move, mouse update, mouse end, or really now the sync is listening to not only the mouse stuff but also the touch stuff and also the sync stuff, the scroll stuff. So it's listening to all that stuff, and that's because we've piped to this generic sync. But really, just it's like a router. It's like it has 3 ends here: mouse, touch, and scroll, and then it's like all of you get the things that you're listening to. Cool. So I'll end kind of with this guy. How am I doing on time?
You're fine.
Yeah? Okay. Okay, so with the capstone here that I showed you before, what's the cool stuff to kind of describe here? Okay, so here, this is something new. Our syncs also take some options here. So here we have mouse and touch, but the only thing that they listen to is the displacement along the x direction. It's a common need of people. So all the other examples, it was like, oh, x and y, woo! But now you can kind of have rails. If you only want to listen to one of them, the x displacement, then you just pass in a direction keyword. Really, generic sync.directionx sounds really fancy, but it's the number 0 if you actually looked in the code. And direction y is the number 1. So like, it's just a way of being reader friendly, but there's nothing that stops me from just writing that and having the same thing. What happens if I do that? Oh God. So now, check it out. So if I move left and right, it's not actually doing anything, but if I move up and down, it's doing, because I only changed it in one place, I can change it in the actual position place. But that's pretty cool anyway. Okay. Let's just keep freestyle it. Yeah. Check this out. So instead of the surface piping to the sync, what if I use the engine.pipe to the sync? Who knows what's going to happen? The engine, remember, listens to the body. It's the entrance to the body.
Only mouse events on outside of the circle.
Yeah, or actually everywhere. So so this didn't work before. Now it's listening everywhere. So what's cool about this is, like, say you had a second surface somewhere else, you can drag on that and have it affect something, not it, but something else, right? Because it's not the surface, it's just this abstract separation of what is my event source and what is the thing that I'm piping to. So those don't have to be the same. So now if I drag on the body, nothing happens, but only on the surface. Okay. What else is cool about this example is that, so we have, before we were moving in both x and y. We didn't have a direction set on the generic sync. And so we had a position that was an array, or a transitionable of an array of numbers. Now we only care about a single dimensional number, so why have an array? Let's just have a number as our transitionable, and that's totally fine. Transitionable can take numbers or array of numbers.
Can you lock a position, lock a direction once you start going in that direction? So let's say you can scroll horizontally and vertically.
Yeah. Yeah. And the Google's Rubik's Cube thing, if you guys have been playing with it, does that really well. It's like you don't know whether you're going up or down, or left or right. So we don't have any built-in directionality. You'll unfortunately have to do that yourself. You can listen on the first update event, and by the delta, if it's an X or a Y, you can tell that. But we want to definitely build that one in. When we have like our swipe left, swipe right, all that directionality support, that'll be part of it. Unfortunately, that's a little bit manual right now. What would you want to call that? Like on left, on you can create it right now, and we'll do it. All right, we'll think of something. Okay, and what else is going on in this? Okay, so I talked about the one-dimensionality. So now in our update event, there's just a little bit more complicated logic for getting, now there's a lot of logic in this, like whether you move left and then go back, or fling it and that's okay, or have you moved further than the halfway point? Do we not have that? Oh, okay, well, yeah, not hard to add. So like the question is, when did the user complete the swipe? And that could be both if he went over halfway, or if his velocity was great enough that even if he didn't go over halfway, it's still going to carry the thing. So all that is, though, is it's just a little bit more complicated logic inside your update event. So here, we're only going to set the position to the far right. Yep. If a certain condition is met, which is whether the current position is beyond some limit. So this used to, or we can add whether the velocity is beyond some limit. So that should be, here it is. Here, sorry, on end. Yeah, if the current position is on beyond some threshold, or if the velocity is beyond the threshold. Great. Otherwise, set it back to 0. And the other cool thing is, okay, so really this entire example is based off of one variable, one guy, which is how far from 0 to the end did you go in pixels. So instead of having, there's going to be two modifiers here, one to control the rotation of the arrow, and another one to move right and left. So one is a rotate modifier, one is a translate modifier. But they're both based off of the one piece of state. And by using a transitionable, it makes it really easy there. You just, in the position modifier, you ask for the position.get, and in the rotate modifier, you ask for the position.get also, just its current translate, except you do a little bit of math to figure out how to translate the translate into an angle. But the important thing is that there's just one truth, one number that you actually care about, and everything else is a consequence of that number. Cool. Let me, in just a few minutes, unfortunately you guys can't you can kind of load this up yourselves, but we have in our starter kit a bunch of examples that aren't in Famous University, a lot of discrete examples. So I just wanted to show you what's possible with our multi-touch support on a phone, if it's doable. Doesn't work. I don't know how else to do it. Sweet. What is this one? So I think this is a rotate sync. So I'm going to put 2 fingers down. Well, let me reload. Okay, so this goes to one of the questions over here is point. Yeah, you, sir. Was what is all the stuff that is outputted? This is still a subset, but is a little bit more information. You can tell how many times I've started, my direction, clockwise, counterclockwise, or I think we derived that from the velocity, the delta, and the angle of the rotate. Okay, so here's it's only a 2-finger thing. 1 finger doesn't do anything. Okay, 3 fingers, not sure what that does. I think it only listens on the first 2 right now. Then there's a question of what if you let go of 1 and move it. We should fix that. Okay, so with 2 fingers, rotate just gives you, it starts at 0 on the angle and moves around, so you can get all that information. Let's go to another one. Oh god, this is not ideal. That was a rotate sync example. Okay, pinch sync. Yeah. Example. So pinch is this guy, pinching in, pinching out. So we have the, how many times we've done it, how many times we've ended, the direction, whether it's expanding or contracting. We have, the delta is always kind of the diff between the last one and the current one. The distance is the total distance between the fingers, and the displacement is how far I've gone from when I first started to when I've ended. So you might start with some already displacement between them, but you don't care about that. So you might start with a distance between them. You don't care about that. You just care about how much have I changed since then. That's what displacement is. While distance just gives you the actual distance between the fingers. We also have, I think there's one more. But that's the basic idea, and we want to just flesh out more of these multi-touch support things that all have the exact same APIs. That's the coolness of it. And you can all register pinch syncs and rotate syncs the same way you register mouse and touch. And we want to keep building, adding more of these things, and honestly lean on our community to do it. One guy already made this awesome contribution where in order to get stable zooming of stuff, you have to emit not just where your fingers are, but the center between them and something else in order to in Google Maps you scale off center, it zooms into that area. So he was like, oh, you need to actually output this. And so we gave it to him. And we're happy to do that. So can't wait to see the things that you guys make. Any questions? Okay.